Okay, I'm going to look at number 2 in section 9.1. Select the function which is a solution of this differential equation. Now, this is not a first order differential equation. It is a second order, and we have not shown the methods for solving second order differential equations in this section. So you might ask, how are you going to do this one? Well, it's going to be just like we did number 1 in this section. You might want to go back and watch that video. It's not This one is multiple choice. It is not multiple guess. I mean, if you're just clicking and guessing each time, then you are not understanding what's going on with this problem. So what they want you to do is, given the different choices, right, for y, find the derivative and the second derivative, plug into this equation, and make sure you have an identity, right? We want to find a function y that satisfies this equation for all values of x, okay? So let's look at the first one here. Again, your differential equation might be different, and therefore your choices or options for solutions might be different as well. This one's actually the solution. I chose it first, but let's see how that comes about. I'm going to take the derivative, and so notice I have indeed a product rule, right? E to the x times sine of 6x. So I take the derivative of e to the x, which is just e to the x times sine of 6x. And then when I take the derivative of sine of 6x, notice that's a chain rule. I've got inner function 6x, so derivative of the outer function sine is cosine of 6x times the derivative of 6x, which is what? 6. So I get 6 times e to the x cosine of 6x. So there's the derivative. All right. Second derivative, well, I'm going to take the derivative of the derivative. First of all, I'm going to take the derivative of this thing, but notice this thing right here, e to the x sine of 6x, is the same as the original function. And I just found that derivative. So the derivative of this thing, just recopy these two things here, right? So up to here, same thing. Now, add the derivative of this thing. This again is a product rule, right? I've got 6 e to the x times cosine of 6x. So the derivative of 6 e to the x is just 6 e to the x times cosine of 6x. But then when I take the derivative of cosine of 6x, chain rule again, derivative cosine is negative sine of 6x times the derivative of 6x is 6. So I get negative 6 cosine of 6x. Well, negative 6 times 6 is negative 36 e to the x sine of 6x. Now I can combine like terms here. Notice the first and last terms are like. They have e to the x sine of 6x. So 1 minus 36 is negative 35 e to the x sine of 6x. And then these two are like terms and they combine, right? 6 plus 6 is 12. So here's my simplified second derivative, which you should do. Now we just plug in, right? Y double prime is this thing we just found. So I'm going to stick that in there. Minus 2 times y prime. So here's y prime. Stick that in the parentheses. Plus 37 times y. 37y, remember, was this. Plug that in. Well, this is an identity because notice if I combine like terms here, negative 35 e to the x sine of 6x minus 2 e to the x sine of 6x gives me negative 37 e to the x sine of 6x plus 37 e to the x sine of 6x is 0. And notice here, 12 e to the x cosine of 6x, look at negative 2 times 6 is negative 12. Same like term, 12 and negative 12 is 0. So hopefully you see that all this combines to just 0. So for all values of x, this equation will be true, and therefore this is the solution. I did a couple of the other solutions that were given to show that they were not solutions. So what's that going to look like? Here's one of the other ones they did. And if you look at it compared to this one, the only difference is they changed the 6 to a 37. So the way we find the derivative is basically the same. We just have this, different constant multiple coming up. So we do product rule again, and we get the following, right? Derivative of e to the x is just e to the x times sine of 37x. And then when we take the derivative sine of 37x, we got a chain rule there again, remember, so we get 37 cosine of 37x times the e to the x. So there's that. Then I have to take the derivative of this to get the second derivative. Of course, the derivative of this thing, like above, is the same as the derivative of this, so I just recopy these first two. And then the derivative of this thing by the product rule is this down here, where this huge number comes from the fact when I take the derivative cosine of 37x by the chain rule, I get negative 37 sine of 37x. So 37 times 37 is this big number. And of course, it's negative. Now I combine like terms. So I've got one of these terms, negative 1,369 of these terms. So it's negative 1,368. 37 plus 37, 74. There's how we combine that. Now when I plug that in, so here's, I just recopied the differential equation, y double prime. So that's this stuff here. Plug that in. Negative 2 times y prime. So I'm just going to multiply both of these by negative 2. So I get negative 2 e to the x sine of 37x, and negative 2 times 37, negative 74 e to the x cosine of 37x. And then remember, it's 37 times y. So here's y. So 37 e to the x sine of 37x. So when I combine like terms this time, so this is a like term, this is the like term, this is a like term, just combine, add the coefficients, negative 1,368 minus 2 plus 37 turns out to be this. Notice these are like terms too, but 74 minus 74 is 0. It goes away. Okay, so here's what it simplifies down to. Now, there's probably a value of x that will satisfy this equation. In fact, there's probably infinitely many, because I know sine of 37x will be equal to 0 infinitely many times. Basically, when 37x is what, 0 or any multiple of pi, or any multiple of pi. So when x is 1/37th any multiple of pi. Okay. Bottom line is it's true for infinitely many values of x, but not all values of x, right? So if I plug in, x equal 1, for instance, I'm not going to get a solution. So therefore, this is not a solution to the differential equation. Okay. I did a couple others, and I want to show you. Maybe you can freeze the frame if you want to review just taking derivatives and second derivatives. This was another option that was given. When I simplify second derivative, I get here plugging in to again, you might want to stop and try this yourself to make sure that you get these values. But when I plug in and combine like terms here, I get this equation. Again, this equation may be true for infinitely many values of x, but it's not true for all values of x in the domain of the function, so it's not a solution. Again, you might want to confirm that you can get these values. And then this is one more of the options that were given, a little bit simpler in terms of the derivatives here. And when I plug into the second derivative, or plug in the second and first derivative in original function, I get this, which simplifies down to this. Again, an equation that's true for some or infinitely many values of x, but not all values of x. And therefore, it's not a solution to the differential equation. This is not a solution. Okay, so this is the way you should do. If you're just checking, you can simply check the options that are given, verify that it satisfies the differential equation, or verify that it does not. Hope this helps.